We're going to do the quick review first. If you have not done that yet, please pause the video, use the word bank down here at the bottom, and fill that in. I might hear some help from the folks in the classroom, but you do not have to say anything, because I understand you might not want your voice on the recording. But if you want to join me, please do. So we have been talking about what? We've been talking about sound. And sound travels in what kind of waves? They're called longitudinal, but the other name is compression. Excellent. And waves can be measured by how far from one part to another repeated part. So that would be wavelength. They can be measured by how many waves pass a given point or how often it happens, and that's frequency. They can be measured by the maximum distance they move away from rest, and that would be amplitude. And blank occurs when the frequency of a sound is the same as the natural frequency of the object. So that's resonance. And examples of resonance are Tacoma Narrows Bridge, crystal stemware, and musical instruments. So if you are watching this video at home on your own, pause that to get those filled in, but we are going to move on. All right, so now all we're going to do on the front of the page is fill in what type of wave each of these are. So this first wave, it says that word right there. So what kind of wave is this first wave? Compression. So we're going to write compression in up here on the top. And then this kind of wave is the kind that has a crest and a trough. So what kind of wave is that? Transverse. All right, so a compression wave is a sound wave, and a transverse wave is a light wave. Now, do we sometimes represent sound waves in an up and down fashion? Yes. But all they're doing is saying that the crests are the compressions and the troughs are the rarefactions. They've just switched it up. But the way that sound moves is like this, not like this. Going once, going twice. All right, so now we got down here, we've got two waves that have a high amplitude and two waves that have a low amplitude. But up here on top, we have what kind of wave? Transverse. And then down here, it's also transverse. What kind of wave do we have here with the compressed dots? Compression. All right, going once, going twice, gone. All right, down here, we've got a high frequency wave and a low frequency wave. That's going to be a high pitch or a high frequency. This is going to be low. What type of wave? Transverse. All right, this literally is a model of the waves that come out of an ultrasound machine. Now, when I say ultrasound, if I told you I'm going to have an ultrasound done, what are you automatically going to think I have going on? Right, that I'm going to have a baby. I got to tell y'all that ultrasound is used for way more than just looking at babies. But it's very rare that someone wants to go, I got my liver ultrasound. Do you want to see the picture? Like, people want to see the little baby picture. People don't care about seeing the other things that you get ultrasounded. For example, I had shoulder surgery, and I got a nerve block put in before the shoulder surgery, and they used ultrasound to find the nerve. So they put the gel on my neck and put the ultrasound here and found the right nerve and stuck the needle in and numbed my whole arm so that way it stayed numb for days, and it gives the arm time to heal before the nerve block goes away and you really start feeling the pain. So ultrasound is used for lots of stuff. I need y'all to understand that this low frequency ultrasound wave is still stupidly high. It's still higher than we can hear. We're still talking like amazingly high, but there are higher frequencies that can be used. So what kind of wave is this? Compression, right. So this an ultrasound is compression waves. It sends these sound waves into the body. Going once, going twice. All right, so now we're going to do some drawing. First, we need to draw a transverse wave and label its parts. So the first thing we need is the rest or the node that runs down the center. And then you need a nice, even, transverse wave. Doesn't have to be perfect, just do the best you can. And now we've got to label the parts. This part at the top is the crest. This part down here at the bottom is the trough. All right, we've got crest and trough. What else do we have to include? Amplitude and wavelength. What's amplitude? Maximum distance it moves from rest. So amplitude is measured from crest to rest. So that's amplitude. And then we also need to measure wavelength. How do we measure wavelength? Run crest to crest or trough to trough. I'm going to do trough to trough just because it's kind of busy up there at the top. But you need to make sure that wherever you draw your line for your crest and for your trough and for your wavelength, that if you put a marble there, you wouldn't know for certain which way it would go. So you can't put it here or here. If I put a marble right there, it would roll down. So we know that's not right. We know that's not right. I can't put it here or here because if I put a marble there, it would definitely roll this way or definitely roll that way. You got to make sure you're right at the top for the crest. All right, and this is the what from trough to trough? Wavelength. All right. Hopefully folks at home have got that. If not, pause and you can finish it up, but we're going to move on to the next one. Going once, going twice. Great, y'all are doing an excellent job. I really appreciate it. All right, so now we want a compression wave. The best way to draw this, I feel like, is the slinky method. So we're going to draw slinkies with the coil close together and then spread out and then close together and then spread out. So these areas where the slinky coils are close together, what is that? Compression. This area where it's all spread out, what's that? Rarefaction. If the parts of a transverse wave are crest and trough, and the parts of a compression wave are compression and rarefaction, and we measure the wavelength of a transverse wave from crest to crest, how do you think we would measure? Yep, or rarefaction to rarefaction. So I'm going to go from the middle of this rarefaction through the middle of that rarefaction. And that way I know it's exactly the same length. You also could go from the beginning of this compression to the beginning of that compression. But as long as you're going from one part to another repeated part, that's the wavelength. All right. Again, if you're at home, you might need to pause, but I think we're probably ready to move on here. I don't see pencils moving. Veronica, you good? Okay. All right, I'm going to pause. Okay, so going once, going twice. All right, so now we're going to draw a compression wave with a low amplitude and a compression wave with a high amplitude. So you need to label which one's which. Compression wave with a low amplitude is only going to have a few coils in the compressions. A compression wave with a high amplitude is going to have a lot of coils in the compressions. And then we're going to do the same thing, low and high for transverse. Node across the center or rest. Low amplitude is going to be how far from rest? Right, like just barely. Do try to make them the same frequency. Like don't do one really fast and, one really slow. Try to keep it the same frequency and make the only thing that you change be the amplitude. So it's the same tone, it's just louder. So this is ooh, and this is ooh. It's just louder. Same tone. All right. Again, if you're at home doing this, pause if you need to, but I think we're ready to move on. Going once. Going twice. All right, so now we have transverse wave with high frequency and transverse wave with low frequency. So again, we need our rest. This time I want you to keep the amplitude the same and only change the frequency. So how would we have a high frequency wave? What do we need to have a lot of?
Like coils and...
Well, this time it's transverse, so we need a lot of crests. Right. And over here for low, we need few crests. So try to keep it the same amplitude and only change the frequency. And so that tone is at the same volume, but this is E and this is ooh. And then last, we've got our high and low frequency sound waves. So high frequency would have our coils happening often. Low frequency would have your coils happening only rarely. Oh, that's no good. Hopefully y'all can infer what's underneath the thing there.
You are currently the only person in this conference.
Great. All right, well, that's all for the notes, so I'm going to end the video. Have a lovely day. Make good decisions. Bye.